1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Mary had a little lamb. The doctors were amazed. So when you speak, sir, you just stand up here and talk. You don't have to lean. You can lean right in and you get that big, deep DJ voice. I have those as well. But unless you're going to stand here, if you're standing here, because you'll have your notes, there's no... Okay, we'll just pop that out and off you go, or I'll put a lapel on you. What would you like?
Probably lapel, but I tend to leave a lapel on and then I start thinking about other people.
We'll need it to come back because I don't know who else is going to need it.
Right, just give me a lapel. Yep. I just got to make sure I turn it on and off.
No, I'll do that.
Let's do, all right, yeah.
You don't touch anything.
I don't touch anything, you turn it on.
Yep.
I'll give you a signal when it turns on. Yep. Okay. Zoom webinar. Can you open up the Zoom webinar for us? Yes, unfortunately. That's the workshop program.
Yep.
This is, we want the forum programs as two.
All right.
It should be on the second slide. But
So that's your first one.
okay, so if you start like that.
Yep.
And if you want to put up the other one, I've got it on the slide.
Yep. Okay,
I've
so
got
it's
the
called?
forum program. That needs to be my first slide. I'll check if that's okay.
So let me get over this. That one? On this screen it says forum program.
That's the one.
Okay.
Right.
It comes up as workshop program in the slides. Yep.
Oh, yeah, that slide's going to be replaced. It's saying in my actual PowerPoint. You just got to copy the bottom one and put that, copy that, put it into my PowerPoint presentation.
Okay.
If not, so delete the other one and just copy that one into the beginning of my slide.
I was going to have this as a go-to point as well going. So like we go, go to.
Yeah, is that right? Yeah. G'day mate, do you mind doing that? Right, hang on, well, hang on.
It should be.
Oh, hang on. Mate, it's okay. I need something. Okay, you're going to unmute me. That's on at the moment, isn't it? So that needs to be off. Okay, thank you. How was it, Annette? Oh, I see. Oh, Brenton's onto it. We've still got 1 minute. With the clicker, how does it work? Yep, that's it. Thank you. Turn that off. Yep. Yep. Hi, Hassan. How are you, mate? We've got that. See Lance. Lance is the AV guy. Talk to him later. After lunch, after morning tea. Yeah, but after morning tea. So we're only worried about morning tea. He's after morning tea. Okay. Yep. Can we press record on the webinar, please? Samuel? Yep. Yep. We'll press record and start recording. So yeah, we're live streaming and recording this session today, everyone. So we will be also going to the audience for questions and so forth. So just be aware, yeah, people are online. Okay, we're ready to go? Yep. All right. So welcome everyone to the South Australian Biochar Forum. Yesterday we had a field day and workshop which seemed to go extremely well. And thank you to Metamorph Engineering for the sponsoring that and for hosting us up in their Nan site. Today, just some general housekeeping, so just please turn off your mobiles. There's nothing worse than getting phone calls as people are speaking. You'll have to use a hotspot for your Wi-Fi. The toilets are down one level. We're going to serve morning tea, lunch and afternoon tea. Will be served with dietary requirements covered. Also, you can refer to the events, ansbig.org events page, and there's the full program on there if you need to look at the program in a digital format. Also, if you haven't already, haven't already booked, we do have places for our networking dinner tonight at the Aqaba Hotel. So just go on to the events page. There's a networking dinner button, and you can book that through any time throughout the day if you change your mind about coming to dinner. Of course, this is where relationships are enhanced and partnerships formed or reinforced. So yeah, just visit that button and book in. Yeah, it should be a really good night. Also, when in town, we recommend staying at Aqaba. So I went to Evoke Ag last week in Perth, and I met a farmer from Esperance, 6,800 hectares, and he introduced me to this little fella. Meet Pierre. Now, Pierre is a small pointed conical snail, also known as Protocolla Cella Barbara. Some of you might know her already. And that downgrades harvests in wheat on the York Peninsula in South Australia. So he might look nice, but he's actually quite a pest for our farmers down there. This is the current method that they use. This is the current method that they use to control Pierre. It's called a snail roller, and it's been quite effective, but obviously it's got to be done at certain times of the crop's life cycle. That's what they use to control it at the moment, snail baits. You can see the poison marking on the top, so just think withholding period when it comes to selling food after it's been treated. Introducing liquid smoke. Now, it's also known as, we call it liquid smoke because it's recognised by the FDA as a smoke, as a food flavourer, okay? But it's also known as pyroligneous acid or wood vinegar. I've been advised by my colleague, Mike the Worm Guy in the US, to refer to it as PA, pyroligneous acid, because it's not always made from wood. And in fact, internally, we've learned that chicken litter makes the best liquid smoke for certain applications, probably more as a biofertiliser than a biopesticide. But yeah, this liquid smoke, a pyrolysis product, is currently sold as a biostimulant. So we've got less withholding periods. The liquid smoke feeds microbes, can build soil carbon at the same time because it feeds sugar to the microbes. It reduces residual effects on soil, water, and human health. Introducing the control, introducing management of Pierre et al. It happens in little patch infestations in the wheat, and instead of spraying the whole hectare with the control, the artificial intelligence, so this is sustainable farming through artificial intelligence, picks up on the image of Pierre et al. When it comes up to that patch of infestation, right, and on to the next patch. You only need, therefore, to spray maybe 15% per hectare. So this is precision agriculture. And the other side of it is that the liquid smoke can be used as an ingredient for a wider product. So yeah, so it's an ingredient with other chemicals. So to reduce their usage, reduce costs and environmental impacts, right? So you can mix it with other chemicals and it'll reduce, right? But at the same time, when you're controlling the snail, you're going to be feeding the microbes, you're going to be reducing the residual effect on the environment. So have we got any producers of liquid smoke in the room? Oh, 2 minutes to go. I've got a lot more slides. So there's a lot of, this is the way these big companies are going. They're switching from fossil fuel-based fertilisers to biostimulants, biopesticides, biofertilisers. So ANSBIG is the peak body for biochar in Australia and New Zealand. That's our vision, Australia and New Zealand as global leaders in the sustainable production and use of biochar. And as you can see, the plant icon there suggests that, this is a potentially renewable resource that we're working with. What is biochar and why roadmap? Is it working? You click on it? No, the link's not there. Just go to our website and I'll come back to it, okay? Okay, we'll play that later. Okay, the what is biochar and why roadmap video is on our YouTube channel. You can watch it later, we'll play it later at the thing. On our resources page, we've got the introduction of biochar fact sheet. So we've defined biochar as storing carbon in a durable form for centuries to millennia. The emergence of commercial biochar industry in ANZ, so the inauguration was in the 2000s, R&D was at national and state levels. The world's oldest field trial is in Wollongbar, New South Wales DPI. We had the Biochar Researchers Network of ANZ, which went inactive from 2014, and that's when myself and a couple of others started ANSBI, so Australia New Zealand Biochar Initiative, in 2017. ANSBIG emerged as an industry group in 2020. So we've got 200 active members, including corporates, entrepreneurs, academics, capital and governments at all levels. Significant library of conference, webinar recordings, economic reports and scientific papers by category. We focus on resourcing, education and communications, innovation, policy and regulations, supply and market development and standards and certification. We've got 20 members with multi-million-dollar projects underway worldwide, and we've developed the world's first biochar industry roadmap, which was launched in June last year in Canberra. So in the roadmap, we've identified the current industry is worth 50 to 100 million per annum. The current production and use is a mere 10 to 20,000 per annum, but extensive expansion is underway with just one project coming online this year that will produce 16,000 tonnes of biochar per annum. We've also got 50 to 100 million tonnes of commercially accessible biomass, residual biomass that's currently being burnt or landfilled in Australia every year. The roadmap has identified the opportunity to scale up to an industry by 2030 with a net value worth of between 1 to 5 billion per annum and production levels of 15 to 30 million tonnes per annum. So that's the roadmap, the front cover. They're all our supporters and sponsors. So thank you to all of those, and there's going to be a lot more that we have to add to the next version, and that's all of the sponsors of the South Australian and WA Forum and also the New South Wales Forum. Thank you very much to our event sponsors today. There they all are: KSI Sawmill, Biogen, Jeffrey's Compost, Riverland Almonds, Highway Group, University of Adelaide, Vital Chemical, Forestry South Australia, Sardi and Metamorph Engineering. Thank you very much for Internet Innovations, who have provided the internet for today. And the reason we're promoting this too is because it's wonderful to get remote access or Wi-Fi for things. So thank you. Thank you very much. Next up on the program, we are very fortunate to have Martin Hazy. So Martin, are you here, Martin? Hi. Would you like to come up on stage, please? So Martin is the Premier, the Chair, sorry, not the Premier of South Australia.
I haven't seen that on my CV.
Yeah, he said maybe next year. But the Chair of the Premier's Climate Change Council, right? So Martin is Hazy MBA, is an entrepreneur, educator and advocate. Martin builds bridges between environmental and economic priorities. Martin is the chair and of the council, and providing independent advice to the Deputy Premier and State Cabinet on reducing greenhouse gas emissions and mitigating and adapting to climate change. In 2014, Martin was elected as the Lord Mayor of Adelaide, a public office he held until 2018. He has spoken at COP21 in Paris in 2015, the World Cities Summit in Singapore in 2018, and COP28 in Dubai in December last year. Martin is also the Special Envoy to Singapore and Southeast Asia for trade and investment for the Government of South Australia. So everyone put your hands together for Martin Hazy.
Thank you very much indeed, Don, and thank you, Melissa, for your keeping me organised this morning, and everyone, thank you for your hospitality. I too acknowledge that we meet on Kaurna land and we pay respect to elders past, present and emerging. And welcome to the delegates from this conference, of course, from Adelaide and South Australia, regional South Australia, and of course also equally beyond the borders of South Australia. Very special welcome. As you know, it's a wonderful time of year to be here in Adelaide with the Adelaide Fringe and the Adelaide Festival, and so much to do, so please do enjoy. I'm going to introduce to you really South Australia's, I think, innovation in terms of its world-leading growth in terms of emissions reduction, and then cite a number of segues between that and biochar. So I'm very, very pleased to be here. I'm principally here, of course, in my role as chair of the Premier's Climate Change Council. I've chaired the council since 2018. And we're an advisory body, as Don shared. We advise State Cabinet with regards to principally three things: climate change adaptation, climate change mitigation, and policy and legislation and regulations which enable the growth of low emissions industry in South Australia. We do a lot of technical work. I often present in front of State Cabinet, and we're one of the stakeholders in South Australia who are helping to achieve probably many of the outcomes, including one which was announced yesterday, which many of you would have heard, that South Australia will be 100% renewable energy by 2027. And globally, please do not underestimate the significance of that outcome. That is extraordinary. We're working towards an outcome of 2030 for 100% renewables. We'll be running 3 years ahead of schedule. And putting that into context, it was only literally just over a decade ago when South Australia had 1% renewable energy in its grid. So over a period of circa 13 years, to go from 1% to take us out to 2027 to be 100% and then become a net exporter of renewable energy into the national grid is actually an incredible achievement. And I had the honour on behalf of the Deputy Premier of speaking at COP28 in Dubai in December late last year. And that very point is not lost on the global community. South Australia's reputation in terms of innovation in the renewable space is very, very well appreciated and very well noted globally. And I do advocate, wearing my various hats, that there is an important nexus between the economy and the environment. I think these matters are now completely inseparable, and we have to consider them together. And South Australia has done that magnificently well, because it's actually, our environmental care has actually become a point of advantage for our economy. And that provides investment and employment for South Australians and a lot of innovation. So many of you are aware of this picture, but it's because we're in it, it sometimes gets lost on us how profound our trajectory has been over the last decade as a state. The Premier's Climate Change Council was formed, we're a creature of a piece of legislation, the Climate Change and Greenhouse Gas Emissions Reduction Act 2007. The council was in fact the first of its type in the nation, established in 2008, and South Australia had the first climate minister, which was Mike Rann, in 2008. So we certainly have a history of kind of leadership in this emissions reduction and renewables space. And that piece of legislation is really the foundation point which has guided us, because that's the piece of legislation which sets the emissions reduction targets in South Australia. And we have been working on amendments to that piece of legislation, which will be going through Parliament this calendar year. So it's important. Our membership of 9, soon to be 10 members, comes from a very wide diversity of skill sets, from agriculture to transport to policy to entrepreneurship to innovation to technology to investment. It's very broad, and it has to be, because we work across literally all industries in South Australia and then help the government set policy which is going to benefit all South Australians and industries within South Australia. So in that regard, it's quite holistic. The work we do is detailed, but our approach is holistic, because it has to be, because we're not an industry organisation per se. We work on behalf of and benefit all industry associations. Now, South Australia. We, of course, will achieve a 100% renewable energy by 2027, but that's part of a wider picture of a 50% reduction in emissions by 2030. And in many ways, I hope that we exceed that target, and then on our way to net zero as a state by 2050. And many jurisdictions around the world, of course, have got net zero targets, legislated or otherwise, for either 2040, 2045 or 2050. And I do hope in the future we can be more ambitious than 2050 in terms of achieving net zero. And of course, at times of the year, including now, South Australia is already running on 100% renewable energy, but it's the average over the 12 months is what we're looking at. But by 25-26 year, we'll comfortably be running at 85% renewable energy as a state. We're currently at 70, and then by 2027 we're moving to 100. But the opportunity there is, with the construction of an interconnector from South Australia into New South Wales, is that then South Australia becomes a net exporter of clean energy into the national grid. So you'll start in future years to start hearing targets like 125% or 150%, 200%, which means that we're not using all of the energy we consume, we're exporting that energy into the national grid for other jurisdictions to consume. And it's, of course, renewable energy, of which, of course, we are very, very strong advocates for. This is a very telling slide, and I often, when I chair a Premier's Climate Change Council meeting, will have this almost as a standing agenda item where it reminds us as to where we need to do our work. And these towers on this bar chart really show you where the emissions in South Australia are coming from. And it's transport and agriculture, which are now the greatest or the largest emitters at 29% and 28% respectively. If we'd been looking at this chart a decade ago, it would have been energy. So we had not decarbonised our energy grid. So it would have clearly been energy, probably sitting at 40% plus in terms of emissions for the state of South Australia. And I often remind the council and the government in as far as don't take South Australia's extraordinarily successful emissions reduction results in the energy sector for granted. There are other sectors which we must continue to decarbonise. So in order to achieve net zero by 2050, you can't rely exclusively on energy as an outcome to achieve that. We could become a net exporter of renewable energy in South Australia, and if we did nothing else, we would still not achieve our net zero target by 2050. So we need to be looking at our transport networks, we need to be looking at agriculture, we need to be looking at industrial processes. All of these actually add up cumulatively to South Australia's result. And of course, everybody asks, land use, change and forestry, well, that's actually working as a carbon sink. So that's, of course, why it's negative at negative 24%. It's a wonderful carbon sink. But the other ones, of course, are the opposite. So we need to lean into this from a policy and a legislation perspective all the time. It's very, very important. I'll touch briefly upon, of course, South Australia's Hydrogen Jobs Plan. Many of you would have heard of it, but there is an incredible amount of innovation and investment going into the Upper Spencer Gulf and the Whyalla region in South Australia in terms of turning our renewable energy prowess into another form of renewable energy which we can store. Much of our energy we cannot store currently, but you can store it when you turn renewable energy into green hydrogen. And you can store it as a gas or as a liquid or as a solid. And this is why we're hearing so much about industry in South Australia and green steel, green cement and other forms of decarbonising heavy industry in South Australia. This is globally significant, and I certainly do see this in my other role as Special Envoy to Singapore and Southeast Asia for the Government of South Australia. It's absolutely captivated the attention of the investment community. And that's an open invitation to ANZBIG in terms of if anyone would like to have a chat about Southeast Asia. I effectively work with fund managers to attract investment into South Australia for larger scale projects of typically 100 million plus. There is a lot of interest in South Australia for our emissions reduction innovations. So that's an open invitation to you, so please do reach out through Melissa and I'm very happy to have that chat. The biochar industry roadmap, which I've familiarised myself, is that I'm going to extend an open invitation to ANZBIG to present to the Premier's Climate Change Council because we have touched upon biochar. We've had industry stakeholders over the years speak to us about biochar, but I think it's something in terms of opportunity for the state, which we would like to learn more about from a technical perspective. So open invitation for over the next 6 months or thereabouts for a member of ANZBIG to come and have a chat with the PCCC and educate us about what successful policy formulation looks like from a state government perspective so that we can help enable the growth of the biochar industry. Can I thank you very much for your warm hospitality? Can I wish you well? I understand that you're off-site today. Can I wish you well today? Here, I think I'm reading your agenda. You've got a very, very interesting and full agenda. So I won't hold you up, and Don, I'll say thank you very much and enjoy the day. Thank you.
Thanks so much. Thank you, Martin Hazy. And we'll accept the invitation, okay, on the policy. So next up on the agenda, I'm very pleased to introduce Melissa Rebick, who is ANZBIG's new chair as of late December last year, our first female chair as well, so it's a wonderful day for women in biochar. And Melissa also does work with Metamorph Engineering in the business development side of things there. And Melissa has put together an excellent program today. She led our working group, and we thank our working group members. We'll come to you later, but you're all here today. So Melissa Rebick has worked across a broad section of stakeholders in the circular economy, agriculture, natural resource management, and water to develop business cases, projects, policy, and solutions to adapt and mitigate climate change. She has spearheaded over 40 projects and programs, with every one of her projects achieved on time and in full with milestones met. Melissa has 25 years of experience as a project developer, manager and applied researcher within South Australia Research and Development Institute, the University of Adelaide, and is managing director of her company Climate and Agricultural Support Proprietary Limited, now trading as Carbon Drawdown Projects Proprietary Limited. Melissa is an experienced communicator, pioneering conferences, developing and delivering workshops, facilitating and developing a community of practices to increase knowledge and uptake and practice change. She has polished written skills, including producing books, publications, papers and long-term media columns. Melissa has networks and stakeholder connections in Australia and abroad, exemplified through her broad range of board experience. Melissa concurrently recently completed a term as an elected member of the Alexandrina Council, gaining increased experience with governance, policy development, business structure, project development and implementation. She is known as a director, a researcher, a consultant, an educator, a board chair, an entrepreneur, a secretary, a writer, an advocate, and a manager and a project business case developer, and the facilitator for the rest of the day. So please welcome Melissa Rebick.
Thank you. I didn't know Don was going to do quite a lengthy intro, but thank you, thank you, Don, and welcome. So on the first day of our Biochar events here amongst esteemed stakeholders, thank you for coming and a very warm welcome. I just wanted to start with talking about the IPCC. It says we're going to blow past the Paris Agreement of limiting global warming to 1.5 degrees. And it's alarming that in 2023 was the warmest on ever at 1.56 degrees above normal globally. The Paris Agreement aims to hold the increase in global average temperatures. Can I have my first slide up too? I don't know. Sorry, yep, here. Yep. So the Paris Agreement aims to hold the increase in the global average temperature to well below 2 degrees. But now world leaders are saying that we're stressing the need to limit global warming to 1.5 degrees by the end of this century, because crossing the threshold will unleash irreversible impacts. And we're starting to see some of those as well. Put your hand up if you've been affected by an adverse climate impact in the last year. A lot of us in the room. So the speed and intensity at which we're burning our carbon budget is alarming. In the last few years, we've been burning and increasing the parts per million globally by 5 parts per million per year. And if going on this graph, it means at these rates, we might reach 450 parts per million or 2 degrees by 2030. We may only have a short time for going on this, looks like about 6 years, but I know Annette's got the right figures, to consume the rest of our carbon budget as we move closer to an ice-free planet with increased deadly extremes. Don't know why that one hasn't come up, so we will, okay. I've got a little video there that might, can you press? I did embed it. There we go. So, yes. So this is just a really graphic video of what one little fire does in terms of putting carbon into the atmosphere. Our whole industry is based around no longer burning biomass and no longer letting it rot or emit methane and nitrous oxide emissions. It's a really graphic demonstration of why there's 50 to 100 million metric tonnes of waste that goes to landfill every year, and the opportunity for our industry to turn that into a valuable resource source being biochar and renewable energy. So the IPCC says to limit the global warming and for rapid acceleration, we need deployment of carbon dioxide removal. While most mitigation activities focus on reducing greenhouse gas emissions, the biochar industry aims to reduce concentrations already in the atmosphere or about to be released into the atmosphere. And I know, Martin, it's fantastic that South Australia is looking at being a net exporter of renewable energy, but globally we have the option, and South Australia has the opportunity to also remove carbon from the atmosphere, and that is we need to be doing that as well. And South Australia being a leader, that is a great opportunity for us to do that. We're only going to do that with a range of policies with immediate actions involving high upfront investments and potentially disruptive changes. There are gaps needed between projected emissions from implemented policies and those from NDCs, and finance flows fall short of the levels needed to meet climate goals across all sectors and regions. Our industry recognises that there is significant global capital to close the global investment. We have investors in this room today, but there are barriers to redirect capital to climate action. Enhancing technology innovation systems is key to accelerating widespread adoption of biochar technologies and practices. our roadmap outlines the key processes to scaling up the most effective carbon removal technologies and practices globally. There is no other material that can achieve so much to cool the planet, while increasing production, sustainability, biodiversity and revenue, and that's why I'm in the industry. Today, I'm excited that we're going to showcase but a few examples of how our industry can accelerate global carbon removal alongside our roadmap that outlines a pathway and quest to cool the planet. So I'm just going to go through a couple of slides about what our industry members have. And just to explain very simply biochar production, and I know Craig Bragnell's going to cover off on this as well. So looking on the left side, remembering that we are pyrolysing organic biomass and also biosolids. And that waste is pyrolysed or gasified, and everything that is burnt off is captured as an energy: syngas, pyrolysis oil, heat energy, and potentially hydrogen. Everything else that remains is carbon and biochar. Biochar is up to 80% carbon. So there's 3 revenue streams that come out of pyrolysis, being the biochar, the renewable energy, which we often forget when we talk about biochar. That's why we need to stress it. And the carbon removal opportunities that are multiple. Biochar recycles carbon from waste, and as I said, there's 50 to 100 million metric tonnes every year that go to landfill or are burned, and this could produce 10 to 30 million metric tonnes per year of biochar in Australia and remove 15 million metric tonnes of carbon dioxide equivalent. We estimate this has a value of 7.5 to 15 billion a year in Australia. We need to remember that biochar, and this is a barrier perhaps to scaling up, that fit-for-purpose biochars are made for fit-for-purpose end use. And so when developing a project, you need to consider the range of feedstocks that are available, the range of technologies that produce biochar at a range of temperatures and a range of speeds. The bio part of the biochar can vary a lot in terms of its activation, its energy, cation exchange capacity, depending on that biochar process. And there is options to add on activated carbon to that as well, which expands the surface area of the biochar, making it even more activated and for additional uses. Pyrolysis variability and case study technologies, I just wanted to touch on. These are all our technology providers available in ANZSB currently, and it's growing. Those technology providers range from the Kentucky backyard kilns to large-scale continuous pyrolysis units, and Craig Bagnell is going to expand on this. Those continuous large-scale units are the ones that are producing renewable energy as well as biochar, but all have the opportunity to achieve carbon removal certificates through various platforms. Vera and Puro are the main ones that we are dealing with as an industry. Okay, great. So I just wanted to touch on a couple of examples. So we have Logan City Council, who is using Biochar technology. So they are a great example, and I'm wanting to bring in local governments of how they're actually making biochar from biosolids and gas. So the gas powers the facility, and I believe there's additional gas utilised in the region, and then they sell biochar and carbon removal certificates. Metamorph that's here today, so we've got Phil Henschel also giving more detail on that project, which actually can make activated carbon as an additional, but makes biochar from almond hulls, and I believe the idea is to use that biochar back into the local areas to increase agricultural production and use some renewable heat energy to power and dry in the facility. But Phil will give more detail. Okay, so just last slide is that there are many other uses of biochar. So the many uses include, in this graph, these pictures, in the top there is, that's biochar and insulation. We have biochar bricks, biochar in antibiotics, biochar in concrete. Biochar can be used to filter water, but it can also be we can also make biochar from biosolids, biochar in roads, we've got presentations on that later today, biochar for agriculture, biochar in bedding, and biochar in the built environment. We're going to talk about that more today as well. Just wanted to touch on biochar and ag because it is my forte. In high energetic diets, they should contain multiple electron-mediating substances. That's published multiple times. Very, very efficient in dairies, in increasing production, profitability, milk yield, but also reducing methane. We need to do more work in that area. 1 gram of biochar has the surface area of a house. Its pores provide a stimulant for microbes. It's a fuel cell. The top 10 centimetres of soil sustains most life on Earth, and globally we have released 50% of soil carbon to the atmosphere. Biochar will capture, store and recycle the carbon back into the soil where it belongs. Then when we increase our soil carbon, it will give us a range of things. A 1% increase in soil carbon, for example, would give us 165 tonnes of carbon dioxide equivalents per hectare of emission reduction, and that's been published by the Soil Industry Group. It would give us 144,000 extra litres of water holding capacity because 1 gram of biochar has the surface area of a house. It would give us 10 to 42% increase in production, pending the application rates, and that's published in a meta-analysis of 14,000 papers. And it will increase phosphorus availability, for example, by a factor of 4.6. These are all the biochar producers from Ansbig. They're on our website as well. Collectively, we aim to, as an industry, better market our members' biochar and technology. Just the second to last slide is the project revenue opportunities, which I've touched on, and they are biochar, carbon credits, renewable energy, wood vinegar, no more waste, increased production. Put simply, our industry can draw down carbon and increase revenue at the same time. I'm done. So thank you very much. And I'm happy to take any quick, if I've got 2 minutes, points of clarification.
Mike, haven't we? Sitting up there. Yep. Any questions quickly for Melissa? Okay, any questions for Melissa? Yes, Heather.
Melissa, what do you think has been the barrier to more widespread uptake?
Of biochar, I think the quantities of biochar available at the moment in Australia, we estimate it's maybe 20 to 30,000 tonnes. Also the consistency of biochar, as I said, that depending on the feedstocks and the technology, the biochar can be quite variable. So we as an industry need to see how we can overcome that and advocate, that we have more consistency in our products, or work through that as a problem.
I worked on actually Don might have helped on this project as well, a project in Lismore. We were trying to get a sizable biochar tyre pyrolysis plant working there, and we worked on that for 2 years and unable to get it through all the layers of government. And it seems to me the big problem in Australia isn't the solutions, it's the problems with councils and bureaucracy, and how do we get through that?
Being an elected member, I think sometimes the system's flawed because those that you need to convince aren't necessarily across the opportunities for our industry. So I guess it's education, and part of our roadmap aims to roll out a huge education campaign. The other barrier is funding of money, and so Ansbig is becoming a company limited by guarantee, and we need to raise capital fast to be able to roll out our roadmap, and at the moment we are punching above our weight with the amount of funding we have in our account. Yep.
Wayne, meet Martin. Yeah. Anyone else? No, that's it, I think, Melissa, for questions.
Thank you very much. Well, thank you. It's going to be an exciting day, and we haven't got any question systems. It's happy to take your questions, and please write them down as you go. But it's my privilege to introduce Professor Annette Cowie. We are so lucky to have her as an ambassador for our industry, for the Australian New Zealand Biochar Industry Group. Annette is a keynote speaker today, and she is an IPCC lead author for the special report on climate change and land and Working Group 3. So she's been very instrumental in getting biochar into the IPCC 6th Assessment Report, and she's a 6th Assessment Report Senior Principal Research Scientist. She's from Climate New South Wales Department of Industries, and she's an adjunct professor at the University of New England. Hopefully I've done that properly, Annette, and it should have been much longer compared to mine, but I know you'll be able to expand on that, and thank you for your presentation.
Good morning, everyone. It's great to be here to talk about biochar again. Apologies to those of you who've seen this presentation before. We've kind of been rolling out the roadmap across the states, and I've been involved in a couple of iterations. I would like to acknowledge that many scientists in Australia and in fact around the world have had input to the science that I'm presenting here. But in particular, I'd like to acknowledge Professor Stephen Joseph, who's actually in Brazil at the moment, I believe. Otherwise, I'm sure he would have been here. As has been mentioned today, evidence of climate change is all around. You can't possibly have missed it. There have been an endless array of droughts, floods, fires, storms across Australia and in fact across the world. And as Melissa has also mentioned, last year was in fact the hottest year on record by a long shot. Interestingly, the last 9 years have been the 9 hottest years on record. And not surprisingly, as a result of this increased temperature, we're seeing exactly what the scientists said would happen as a result of climate change. Sea level is rising, the polar ice caps are melting, and we're seeing extreme weather events across the world. Now, the international community has been trying to do something about it for quite some time. The UNFCCC, the Framework Convention on Climate Change, came out of the Rio Earth Summit way back in 1992. There have been successive attempts to control greenhouse gas emissions, but so far they haven't had a great deal of success. But we're counting on the Paris Agreement being more successful, because compared to the Kyoto Protocol, the Paris Agreement now has all countries on board adopting targets. Their own targets, the so-called nationally determined contributions, NDCs. The aim of the Paris Agreement, as Melissa mentioned, is to limit global warming to well below 2 degrees and preferably no more than 1.5 degrees. And the Paris Agreement identifies that in order to do that, we will need to reach the position of global net zero in the second half of the century. So net zero is a position in which anthropogenic greenhouse gas emissions are balanced by removals, that is essentially carbon sequestration. The UNFCCC is guided by science synthesised by the IPCC, the Intergovernmental Panel on Climate Change. Now, the IPCC is a group of scientists, all volunteers who are brought together, nominated by governments, for each successive report. So it's a different group of people every time, the best experts at the time for the topic that's being assessed. Each cycle, there are special reports, and then there's the assessment report. So most recently, they completed the 6th assessment report cycle, and they produced their report in 3 parts. Part 1 was released at the end of 2021, and that's basically the climate science. And it reported that interesting graph there which shows the near linear relationship between CO2 emissions and warming, which essentially says when we put CO2 into the atmosphere, it stays there permanently and causes warming. The most important thing we can do to stop climate change is to stop putting CO2 into the atmosphere. That report put together the science that at the time said unless there is immediate, rapid and large-scale reduction in emissions, limiting warming to 1.5 degrees will be beyond reach. Well, as Melissa mentioned, the IPCC has now concluded we've got past that point. We can't limit warming to less than 1.5 degrees. The best chance we've got is coming back to it after overshoot. The second part of the 6th assessment report is the one that looks at impacts, adaptation and vulnerability. And it told us what we already know. The impacts of climate change are, as we've seen before, just going to get worse, and that's going to be pretty bad for human systems and the environment, particularly for agriculture, particularly in Australia, which already suffers from a variable climate. Now, the third part of the sixth assessment report is the part where I was one of the authors, and it looks at the opportunities for mitigation. It has some kind of good news and some bad news. The good news is that the rate of growth of emissions has finally slowed, but we're certainly not on track to limiting warming to less than 2 degrees. The current policies, there in the red, have slowed the rate of growth. The current NDCs would slightly reduce emissions. But if we wanted to stay below 2 degrees, we'd have to follow that green path, or 1.5 degrees, we'd have to follow the light blue path. We're a long way away from either of those. The other part of good news in that report is that there are, in fact, many options for mitigation, and a lot of them have co-benefits, and a lot of them are affordable. But of course, there are also trade-offs for many of them that need to be managed. The land sector has a really big role to play, particularly in carbon sequestration, but it certainly can't do it all. This report clearly laid out that we're going to need carbon dioxide removal in order to reach that position of net zero. In fact, it's spelled out in a sentence in the summary for policymakers, which says, the deployment of carbon dioxide removal to counterbalance hard-to-abate residual emissions is unavoidable if net zero greenhouse gas emissions are to be achieved. This is a really big opportunity for biochar. The report actually canvasses something like 2,300 different pathways that would allow us to limit warming to less than 2 degrees. So there isn't just one trajectory, but this is a stylised trajectory showing what it would require to get to under 2 degrees. In orange are the non-CO2 greenhouse gases, in grey are the fossil CO2 emissions, and in green we have the carbon dioxide removals. So the first thing that needs to happen is that emissions need to peak before 2025. It's 2024 already, despite the date that was on the first slide there. So this is just around the corner. We need to halve emissions by 2030, and we need to reduce methane emissions by 30% if we're to keep warming to 1.5 degrees, or at least minimise overshoot. And we need to ramp up carbon dioxide removal. We need to reach a position of net zero CO2 by about 2050, and net zero greenhouse gas emissions will come a bit later in the century. As Melissa mentioned, the IPCC identifies a range of different technologies for carbon dioxide removal. Some of these are fairly obvious, like planting trees or building soil organic matter. Then there's BECCS, bioenergy with carbon capture and storage. So if you use biomass to generate energy, you capture the flue gases, then you condense them and pump them underground, geosequestration, you have a negative emissions process. A low-tech solution is enhanced rock weathering. So that's taking basaltic rocks, crushing it very finely and spreading it on the land, or in fact in the ocean, where it will weather naturally and take CO2 out of the atmosphere as it weathers. On the other hand, high-tech solution, DACS, direct air carbon capture and storage, involves mounting fans and sucking air across a solvent. This is ambient air, which traps the CO2, and you do the same thing with geosequestration. It takes a huge amount of energy. They're currently doing this in Iceland, but I have concerns about this as the major solution that seems to be being pushed in several circles. Then there are some more, novel technologies involving the ocean fertilisation, so that's adding nitrogen, phosphorus or iron to the open ocean where it's actually really low in nutrients. You can encourage algal growth, and that will take CO2 out of the atmosphere as the algae grows. And then when it dies, it sinks to the ocean floor where it essentially stays there because there's no bugs and oxygen for it to decompose. Ocean alkalinisation is, as it sounds, adding alkali materials to the ocean, which could actually be beneficial, for example, to save the barrier reef, which is currently suffering from ocean acidification, so this could counteract that and allow corals, for example, to survive. And then, of course, there's biochar. Now, I like to think of biochar as land-based CCS, safe CCS. Normally, biomass is part of the short-term carbon cycle, so as plants grow, they take CO2 out of the atmosphere, store the carbon in their biomass, then as the plant litter or organic matter decomposes, it returns the CO2 to the atmosphere through respiration. But if we take that biomass and pyrolyse it, that is, heat it under low oxygen, we create this stable product, biochar, which when we use it as a soil amendment, essentially is inert, decomposes very, very slowly. We know that biochar is very stable from science that has looked at its structure. You can see it has these benzene rings, which are essentially very difficult for bugs to decompose. And recently, a group of Danish scientists have determined that the major constituent of biochar, at least if it's made at over 550 degrees, is what they call inertinite, which is what they find in coal. And they say it has a durability of millions of years. The IPCC has classified carbon dioxide removal methods according to their removal process and their durability. So they've identified biochar as a biological removal process, so therefore it sort of fits within the nature-based solutions, but it has a much greater durability than the other so-called nature-based solutions where you're storing carbon in vegetation or soil organic matter where it's vulnerable to decomposition and lost to the atmosphere. The IPCC's report looked across the literature and concluded that biochar mitigation potential by 2050 could be up to 6.6 gigatons of CO2 per year, at quite a reasonable cost compared to some of the other methods. You can make biochar at many different scales. Those of you who were at the field tour, was it a field tour? Sorry, I'm not sure. Yesterday, will have heard all about it, and I think Craig might be talking about it later today as well, how you can make biochar. But I want to talk about the science and how it contributes to climate change mitigation. So I've talked about the fact that pyrolysing biomass will allow the carbon to be stored for centuries to millennia, or even longer. Some other ways biochar contributes to climate change mitigation, and another removal method, is that this long-term field trial that Don mentioned in northern New South Wales has demonstrated this phenomenon of negative priming. Having biochar in the soil actually stabilises the existing soil organic matter and helps to trap new organic matter and increase the soil organic matter level, in addition to the carbon in the biochar. I'll come back to that in a minute. Biochar is also able to reduce nitrous oxide emissions from soil. Now, nitrogen in the soil naturally, through denitrification, is released as nitrous oxide, which is nearly 300 times worse than CO2 as a greenhouse gas. I'm not sure if Lynn's going to mention that, but if not, we can discuss the science behind that later. Don't have time for that one now. As has been mentioned already, when you pyrolyse biomass, you release syngas as well, a combustible gas that can be used as an energy source, so you can avoid greenhouse gas emissions from fossil fuels. Also, many of the biomass materials that we use for making biochar would naturally release methane and nitrous oxide in their current processes, the way we handle them, such as chicken litter, which releases a lot of nitrous oxide and methane. So if we make it into biochar instead, we can avoid those emissions. Back to this topic of negative priming. This is some really exciting research that was undertaken by Han Weng, who's now somewhere here, at this institution. Thank you, Lynn. And he's demonstrated how biochar is able to trap the new soil organic matter. So it's in these form of micro aggregates, which are very stable little heads, we call them in soil science, which essentially physically trap the organic matter and stop the bugs being able to eat it. And so having applied biochar, particularly maybe in this soil which has a particular form of minerals, it's able to create these very strong little pads that protect the organic matter. But this phenomenon has now also been recorded in several other soil types around the world. And what this means is that you can essentially overcome what we call soil saturation. It's been generally accepted by soil scientists that the soil has a finite capacity to stabilise organic matter. But when you add it as biochar, you completely avoid that ceiling, which means that the more biochar you add, the more you can build soil carbon. So you can keep ratcheting it up, unlike if you were adding the same biomass in the form of compost or manure, because then it would reach that steady state where decomposition is equalled by the amount you're adding. As Melissa mentioned, using biochar as a soil amendment also has some potential to improve soil properties. She listed the fact that it can increase water holding capacity and nutrient retention. It's usually an alkaline material, so it's a liming material. If you apply it at high rates, you can increase aeration, you can stimulate biological activity. Interestingly, it also immobilises contaminants such as heavy metals, and it's been observed to enhance germination and plant growth. And it can reduce fertiliser requirement because it enhances nutrient retention. But in case that sounds too good to be true, please be aware that biochars are all different depending on what you make it from, the feedstock, and what soil you apply it to and at what rate. So you do need to choose the right biochar for your particular application. What research has demonstrated is that biochar is most effective if it's mixed with nutrients, either when you're pyrolysing it or afterwards. For example, poultry litter makes really good biochar because it's a combination of the poultry manure plus the wood waste that's used as a bedding material. But you can add nutrients in various forms, organic or synthetic, when you're pyrolysing biomass to make the most effective biochar. And it's most effective when you apply the biochar right near the plants, near the roots, so that it's there in the rhizosphere, the zone around the roots. And some really interesting research has demonstrated that in the presence of biochar, there's less energy required for nutrients to cross the cell membrane and enter the plant, so it enhances nutrient uptake. A meta-analysis on the effect of biochar on plants has shown that biochar generally has a positive effect on various different measurements you can take to show the health of plants and the growth of plants. So it increases photosynthetic rate, it increases transpiration, it increases chlorophyll activity, and that leads to increased total biomass and increased crop yields. I mentioned that it can be effective in addressing contaminated soils. So this illustrates a number of different chemical reactions that occur on the surface of biochar between biochar and heavy metals that allow it to reduce the bioavailability of heavy metals and reduce the uptake. So I think Melissa has mentioned most of these points, which is a summary from the paper that we call How Biochar Works and When It Doesn't, and it reviewed the general state of biochar science just a couple of years ago. Stephen Joseph led this paper, and it found that on average biochar increases crop yields by 10 to 40%, and this is most effective in sandy soils where it enhances the water holding capacity and nutrient holding capacity, and in high P fixing soils, which are generally found in the tropics. Increases phosphorus availability, on average 4.6 times, and I mentioned how it reduces tissue concentrations of heavy metals, reduces non-CO2, particularly nitrous oxide emissions, but also methane emissions from rice paddies, and I mentioned how it's most effective if placed in the rhizosphere and mixed with nutrients. There are some nice examples of how you can integrate biochar production with our existing agricultural systems. For example, by taking plant residues or manure, pyrolysing that, using the heat and CO2 to, for example, warm glasshouses, feeding biochar to animals so that they then distribute it around the paddock, etc. And so if you have these integrated systems, you can address many of the SDGs, the Sustainable Development Goals, simultaneously. I'm sure I'm running out of time, right? Okay, good. So the big challenge is, how do we get enough biomass to make enough biochar? We have residues, of course, but we really have many applications for biochar, so producing more biomass so that we can make more biochar is the challenge that we all need to address. There are ways we can integrate biomass production with our existing agricultural systems. For example, through shelter belts, through filter strips, to reduce runoff into waterways, for example. We have some trials in New South Wales trialling a range of different local eucalypt species for biomass production as short rotation woody crops. And these are all ways that we could produce biomass at the same time, not competing with agricultural production. Okay, I better go faster. So back to the demand pool for biochar. I mentioned that the Paris Agreement has identified the need for net zero. So in response, countries around the world have adopted net zero, as Martin mentioned. About 151 countries now, in fact, either have implemented or have announced net zero targets. And Australia is one of those, and in fact all our states already had a net zero target for 2050 or earlier before it was announced at the national level. And certainly South Australia has the same target of net zero by 2050, as Martin mentioned. The Australian government has implemented incentives for companies to help with this challenge. One of these is the Climate Active program, which gives carbon neutral certification for products or companies or events or buildings or precincts even. Armidale's trying to get it for a precinct at the moment. And internationally, there are similar programs encouraging companies to adopt net zero or carbon neutrality targets. It's also going to become mandatory. We have internationally the ISSB, which has released this thing called IFRS-2, which is the climate-related financial risk disclosure standard, and that has been implemented in several countries around the world already, including in Europe, and now it's coming to Australia. There's been a series of consultation papers released by Treasury, and last October they released the exposure draft of the Australian Sustainability Reporting Standard. And in fact, if you have any comments to make on it, they're due tomorrow. So it's not quite too late to comment on that document. So this is going to require all the big listed companies to report their emissions starting in July. So once companies start to have to disclose their emissions, they'll be much more interested in reducing their emissions. So just to clarify what I mean by carbon neutrality is a position in which the emissions of your company or country are balanced by removals, that is carbon sequestration, and then any residual emissions are balanced by offsets. Now those offsets could be emissions reduction or could be removal offsets, but they're projects undertaken by somebody else and you purchase the carbon credits to counterbalance your residual emissions. Certainly, carbon neutrality and carbon offsets have had a bit of a bad name lately. There have been lots of headlines suggesting that there's dodgy credits out there. Many of these are associated with international avoided deforestation projects. But there's also been some headlines locally criticising, for example, the soil carbon methods under the ACCU scheme. And the voluntary carbon market is certainly very aware of this and has been working hard to resolve it. There's several different initiatives working towards ensuring that there are not dodgy credits being created and that people who use the credits are buying the right number. There's also recently been this ISO standard, ISO 14068, on carbon neutrality, which sets out how to make a credible carbon neutral claim. And this is an example of a carbon neutrality pathway that comes from that standard, showing that initially a company would be able to make a claim when it is able to demonstrate that it has reduced its emissions internally and it has offset its emissions with emissions reduction credits. But over time, it will need to switch towards removal credits until it reaches a point of net zero, either within its own boundary or by purchasing removal credits. So just looking at my list from before, when we store carbon through pyrolysing biomass, that's removal. When we stabilise new organic matter, that's also a removal. When we reduce nitrous oxide emissions, that's emissions reduction. If we displace fossil fuel emissions or avoid emissions from our BAU biomass handling, that's reducing someone else's emissions, so we can't actually claim that as a benefit of our biochar project, but somebody else would be able to claim credits, at least theoretically. Melissa mentioned already that there are several platforms available to give carbon credits. Puro from Finland is the most prominent, creating the corks. There's also the European Biochar Certificate and Vera methodologies, and the Climate Action Reserve released a method for public consultation late last year and is apparently due to publish next month. All of those platforms create credits just for the carbon stabilised in the biochar, and that quantity of removal is adjusted for the supply chain emissions. They don't create credits for the other aspects that I mentioned. Microsoft has purchased credits created in Australia through the Puro platform. And in Australia, the main approach we have for reducing emissions is through the ACCU scheme. Now, it doesn't have a method for biochar yet. It does have the soil carbon method that allows you to use biochar, but you have to subtract the amount of carbon in the biochar, so that's not very helpful. But we are hopeful that under the new proponent-led method development process, which was a recommendation of the Chubb review, we will have the opportunity to propose a biochar method. A biochar method will have to meet the offset's integrity criteria, which means that it needs to be able to be counted by Australia towards its mitigation obligations. It needs to have science to support it. It needs to be measurable. It needs to be additional, that is, it wasn't going to happen anyway, and it needs to deal with permanence. With regard to whether we can count it, well, Australia doesn't currently count it, but there is an optional method that we could introduce that would allow us to include biochar in our national greenhouse gas inventory. I've already mentioned several aspects about science. Definitely the science is there to demonstrate that biochar is effective as a removal strategy. I haven't talked about how easy it is to measure it, but you can in fact estimate the amount of carbon stabilised by pyrolysing biomass just by doing a chemical assessment of the biochar itself. You don't have to dig up soil samples to see where the carbon's gone. So it's very much easier than a soil carbon project to estimate abatement and to verify it. So, in summary, the science is there. Biochar certainly is an effective and credible climate change mitigation strategy that delivers carbon dioxide removal. Finally, that potential is being recognised, and the need for drawdown carbon dioxide removal to get to net zero is also understood. So the time is ripe for us to promote biochar as a safe and durable carbon dioxide removal method that has multiple co-benefits for society and the environment. Thank you.
Thank you, Annette. That was fantastic. We'll have a couple of minutes, or a minute or so leading into our break time for questions, but we do have a discussion session for 15 minutes before lunch, which will include Annette on that as well, with our next 3 speakers after the break. So I'll just allow 1 or 2 questions now, and then please write down any other things that come up that Annette might be able to answer later.
Thank you, Annette. Great summary there. How long do you think a biochar method would take to get through government and actually available and active?
That's an interesting question. We don't actually know yet when we'll even be allowed to put one up. They've introduced interim guidelines on getting ready for the process. So I am aware that there are people out there already generating methodology concepts for various other mitigation strategies. So I think we should be joining them and developing our own, and to be ready for when we have the opportunity. But the process is that you submit an expression of interest, and then they will choose which ones get developed further. So that might seem a bit strange. If it's proponent-led, why can't they let everybody do it? But their intention is to kind of hold hands with whoever is developing a method so that they can make sure that they know what they're doing, and all the way through to drafting the legislation. So I think the anticipated timeframe, once it does actually open, would be probably about 2 years. Yeah, maybe just.
Craig?
We'll take those 2 and then we might go to... time, we'll have to come back down from where to...
Fantastic talk as always, Annette. Thank you on behalf of the industry. I guess in terms of IFRS and the international standards for financial disclosure reporting coming in, Jim Chalmers announced, obviously under ASIC, that financial disclosure reporting is going to be occurring here, and you mentioned that. For the benefit of the industry, what's your thoughts on where that's headed versus, I guess, voluntary methodologies, and also under the ACCUs scheme, the ACCUs credits, versus, I guess, we know the greenhouse gas protocol sitting behind the financial disclosure reporting and the harmonisation of methodologies for people so that they understand emissions and sinks?
I think that's probably too difficult to answer in the time available. There's lots happening internationally under the Paris Agreement with respect to where emissions trading is going to end up under Article 6.4. It's still under negotiation. I think we can be sure that there is going to be demand for biochar credits either under the voluntary market or under mandatory markets and under compliance markets. And now that mandatory disclosure is coming in, there's going to be even more demand. So let's worry about the mechanics of it later.
Thank you. I'll just take this last question and then
Yes, as a climate activist for about 55 years and a carbon farmer for 40 years, I have a fundamental question, and that is that given Indigenous land management practices, which focus largely on cool fires to manage the landscape, how come, even if it's only a relatively small potential, how come there is so little biochar on our land? No.
Mm-hmm. A very valid question. There actually is quite a lot of charcoal in our soils if you test it through the chemical methods that charcoal as in the product of incomplete combustion. So Indigenous burning practices are different from pyrolysis, but they do create a similar compound in black carbon. So there is in fact a reasonable amount of black carbon in our soils. But what you find is that it's actually quite mobile in the landscape. So a lot of the black carbon that's been generated through fires over the centuries is now in the bottom of lakes and oceans because it does, over time, it's carried through the soil profile and in runoff into waterways and then out to sea, where it sinks to the bottom and is trapped in sediments and continues to sequester the carbon. Obviously not so beneficial from an agricultural perspective once it's in those places. But Jan Shemstadt, who used to work here, used to say, well, if biochar is so stable as we all think it is, why aren't we up to our armpits in it? So I think he was thinking similarly to you, but then eventually realised that that's where the carbon was ending up.
Thank you, Annette. Thank you for all you do for our industry. We are very, very fortunate to have you as our ambassador. I do have some wine over here. I've just got to open the box to put it to Annette. So thank you so much. We can put our hands together for Annette. Thank you. Stay on this in a row. Our wine has been donated by Torbreck Wines to thank our speakers as well, who are very interested in biochar. So thank you to Torbreck Wines. And we can have some morning tea now and be back by 10:50, so we have 20 minutes. So we look forward to seeing you back here shortly.